Hello friends, welcome to my channel Chemistry with DB. So in this video, I'm going to explain the SN1 and SN2, the two reaction mechanisms of hydrolysis of haloalkanes. The other name for hydrolysis of haloalkanes is nucleophilic substitution reaction. Now, in an ordinary nucleophilic substitution reaction of a haloalkane, what happens is you add aqueous sodium hydroxide to a haloalkane and you get an alcohol and a sodium halide. In ionic form, we can write it in this manner. Now, what happens in an SN2 reaction, that this takes place in case of primary haloalkanes. Now, here the CBr, bromine is delta negative and carbon is delta positive. So what happens is that the nucleophile, the hydroxide ion, this attacks the delta positive carbon, and as this gives rise to a transition state, which is I can write it in this manner. So while the bromine is still attached to the carbon, the OH group also joins, and this gives rise to this transition species with a negative charge. After this, the CBr bond breaks and you end up with hydrogen. So you have got ethanol here, and the bromide ion gets free. Now this is called an SN2 reaction because there is only one step reaction and there are two species involved in the slow rate determining step. This is why it's called a SN2, and this takes place, mind you, in case of primary halogenoalkanes. Now let's see what happens in case of tertiary halogenoalkanes. So let's say if you have 2-bromo-2-methyl propane, that haloalkane, which is a tertiary, then in the first slow rate determining step, what happens is, because you have already known that the tertiary carbocation forms, and tertiary carbocations are much more stable than the primary carbocation which forms in case of the earlier SN2. So as a result of this, in the first step only tertiary carbocation forms, and in the first step afterwards the OH minus, which is the nucleophile, that attacks the carbocation, and this gives rise to the alcohol. A tertiary alcohol, right? And the halide ion had formed in this step only, in the first step only. So it's a two-step reaction, as you can see. The first step is the slow step, second step is the first step, and only one species is involved in the slow rate determining step. This is why it's known as a SN1 reaction mechanism. The secondary halogenoalkanes, they can take place by both SN1 and SN2. That means through the transition state or in the two steps. I hope this SN1 and SN2 mechanism type are clear to you now. And if you like this video, please like, share and subscribe. And I look forward to see you on my next video. Take care. Bye. Thanks for watching.